to know the reason behind the solid principle. So, solid principle was introduced by Robert C. Martin, and later Michael Feather introduced the solid acronym. And the main feature was to reduce the dependencies so that a block of code can be changed without affecting another block of code. And in that way, it can develop less coupled code. And few other benefits are it can we can write clean code. Code can be easily maintainable, scalable, and redundancy can be minimized, and code can be easily tested, and readability and reusability will be maximized. And solid stands for there are five principles. Those are single responsibility principle, open for extension, closed for modification principle, list scope substitution principle, interface segregation principle, dependency inversion principle. So the first one, let's discuss about it. The single responsibility principle. It tells that a class should have only one reason to change, and it should have only one responsibility, and it can have multiple members as long as they are serving that one responsibility. In that way, a code can be created with lower coupling, and we can organize the code pretty well. So let's see one example. Uh, let's take the employee application. So with employee application, it comes along with lots of functionalities like calculating the salary, calculating their time sheet and hours, then department-wise generating the reports. So in the first case, what has been done in class employee, all the methods are written, and which will make the class very fat, and the testability and readability will be reduced. And whenever we want to introduce some new changes to that code, it will be very difficult. So the solution can be we can follow the first single responsibility principle, and we can break down the employee class to multiple classes according to their functionality, like employee salary class containing the calculation of salary and displaying or printing the salary, then employee hours so that it can calculate the hours or time sheets, then department details, like that. So next one is open for extension, closed for modification principle. And before that, I want to ask Manasi, do you want to add something? Okay, then let's continue. And open for extension, closed for modification says that software modules should be open for extension but closed for modification. So we can stop ourselves from modifying the existing code, and which can cause potential bugs in going forward. And let's see one example for that. Here it is an example of student info class where it is taking one student object and checking whether it belongs to science class, or the instances belong to science class or commerce class. According to that, it does give you the stream name of that particular student. But in this but in this approach, what happens? Suppose we are going to add one more string, let's say art stream, then we have to modify this. Then we have to add the code changes into student info class itself, and which violates this principle, open for extension and close for modification principle. So in that case, what we can do, we can create a separate class like a student info, which has the functionality uh, of a method called stream name. And later we can create child class that can extend student info, like science class, then commerce class. Then if we are adding more class, one more new class, let's say arts, then we can easily create new class. Uh, Public class arts extends student info. Then the third principle is Liskov substitution principle, and it was introduced by Barbara Liskov, and it applies to.
Vijayalakshmi, wait.
Yeah, sure.
With the first two principles, any code implementation do you have?
I think last time you said that it will be only theoretical. That's why I have not prepared.
Okay, it is theoretical majorly, but
Yeah,
do you have any sample codes available with you, means where the particular concept is implemented? We are not expected to run the code. That
yeah.
is
That's
not
why
required.
I'm. Yeah, I have not right now. I don't have. That's why I have inserted this code
Hmm.
snippets.
Okay, ठीक है. No issues, no
I
issues.
hope this is fine.
Yes. Okay. Fine. Before we jump to the third principle, guys, first of all, I'm having some questions for you. Right? First question is like, is the solid principles and design patterns are similar or different, or they are interconnected?
Interconnected.
Okay.
Interconnected, Mansi.
Okay. How they are interconnected?
Means,
Like,
yes, sorry.
yeah, just go on.
Yes, Kavita.
Yeah, suppose when you use the design pattern, when you follow the design pattern, it means that you follows the solid principle also, because means you are using the interfaces and you are using the concrete classes. So concrete classes means that, Mansi, you means there is the single responsibility come into the pictures.
No, but not necessary, na Kavita.
Yeah.
I'm creating classes, I'm creating interfaces. It's a part of Java as a programming language because it is following the OOPS concepts. OOPS concepts are different. Solid principles are different. I'm creating classes and interfaces. It's a part of a OOPS concept. It's a part of Java programming language. And
Right.
not necessarily I'm writing a class which is following the single responsibility principle. Java never says that, na?
Yes,
For
Mansi.
Java, if you are writing class ne opening bracket and closing bracket, and inside that if you are following the syntactical rules and regulations, the class is defined.
Yes.
Maybe we can say that in order to follow one principle, we must follow another one. For example, for Liskov substitution, we should follow it extend kind of open close principle as well.
Okay, but not necessary, na?
So not necessary, but their designing approach, which will give you good code in return. That is the thing.
Okay.
That
So,
my thoughts. So you can add.
okay. Any other answer? Janvi? Yes, Pranita. Yes, please.
Yeah. So, solid principles are basically just the guidelines. I
Hmm.
mean, how should we maintain our code? And
Hmm.
while design principles are the implementation of that. I mean, not for only for the solid principles, but
Hmm.
generally the what problems we face
Hmm.
and the continuous problems we are facing, we solve
Hmm.
that by design patterns, and we
Hmm.
may or may not use solid principles in that, because
Hmm.
solid
Hmm.
principles are just the guidelines. It
Hmm.
is
Hmm.
not mandatory that we should implement it in design
Hmm.
patterns.
Hmm. Okay. So basically, guys, please try to understand what Pranita says is very correct. Solid principles is a generalized concept. Means if I want my code should be maintainable, if I want my code should be what you can say good, right? Then there are certain principles which they have defined. As per your requirement, you can try to implement them. But you must implement them. That is not compulsory, but it is recommended to implement them. Okay. And maybe there could be situations, and design patterns, as we have discussed, is the solutions for the problems which may occur repetitively while you are designing your code. So design patterns are nothing but the solution for that. So there is a possibility that maybe some of the design patterns are somewhere related to the principles which has been designed or discussed, right? But not all design patterns are connected to solid principles. Am I right?
Yes, Mansi, right.
Right, so not necessarily they are connected. If you are following the solid principles and according to that you are trying to write down the code while doing the design pattern, it will be good, it will be nice, but there is no compulsion. So if I try to establish a direct connection, right, that is compulsory connection, then that compulsory connection I personally feel I'm not able to find it out. That is my opinion. Guys, what do you think? Yes, no.
Yes, Mansi.
Yes, it's right, Mansi.
Prashant, what do you think?
Yes, Mansi, you are correct.
Right. So basically, these are the two different scenarios. Both the scenarios are somewhere dedicated to make the programmer's life easier, right? To make my code more readable, more maintainable, right? More manageable. That is the purpose of both the things. But solid principle is what you can say is the most generalized concept, right? And design pattern is the solution for the frequently design pattern is the what you can say a solution for the problems which I face frequently on a particular situation. Okay. Okay, so with the solid principles, I think so. Let's revise the first two principles before I think so we can move for the third one. So first principle is what? Single responsibility principle. Right? So before I discuss the single responsibility principle, or we just revise it, I wanted to revise two terminologies over here. Right? First one is there is one terminology, something called as cohesion, and another terminology which is coming into the picture is something called as coupling. So anyone from our group is able to tell me what is cohesion and coupling? Yes, guys.
Cohesion means, Mansi, the dependent means the dependency between the component, if I'm not wrong.
No.
So then coupling means that? Okay. No, Mansi, no idea.
Okay. Anyone is having any idea what is cohesion or coupling? I think so. You must have heard about the term something called as the couple is loosely coupled or tightly coupled.
One class is dependent upon another class.
That is,
That is coupling.
it is dependent, I will not say, but they are connected
Related
to each other.
Yeah, that's right.
Means I'm having two classes which are connected to each other, and if I'm making a change in one class, it is going to have a direct effect on the another class.
Another
Whenever
class,
this
yes.
kind of situation is going to be there, it is
Tight
something
coupling.
called as tight coupling.
Tight coupling, right.
Right. And loose coupling means the
They are not
contrast of this
independent
situation.
each other.
Yes, yes, yes.
Independent.
We can say like that cohesion is inside a module, that all data members are dependent on each other, but coupling is like outside the module, the dependence outside the module.
No, I didn't get your point, Vijay Lakshmi.
Like cohesion is the degree to which the data members inside a module, suppose class, belong to each other, belong together.
No, that is not cohesion.
Okay.
Cohesion means, cohesion is a concept or term which is used that whenever I'm designing any component, that component should follow the cohesion concept. Means for whatever purpose you are creating a class, that particular purpose should be get served. Means for example, if I'm creating a class something called as employee, right? Then in employee class, I should have a information only about employee. Okay, or another example, let me just give you a real life example by which the things will be clear. Suppose suppose I'm having some startup, I'm having my own company. So in my company, guys, what do you think? I should hire 3 to 4 people who are having some knowledge of accounts, some knowledge of HR, some knowledge of, let's say, development, and some knowledge of let's say testing. Shall I hire three to four people who are having this multi-skill, or I should have a one specialized person who is dedicated to that?
Specialist.
Means in short, you are using a cohesion. Are you getting, guys?
Can you just repeat once again, Mansi?
Okay. Now, in my example, as I have discussed, I'm having a company. In my company, there are various requirements. So I require to maintain the accounts. There should be some HR related job, some development related job, and some what you can say testing related job is there. So shall I hire a specialized person for each job, or shall I hire one person who knows a bit of account, bit of HR, bit of development, and bit of testing? Which is the better one, Vivek?
Second one is better because we have all the fields knowledge.
Okay. But don't you think this will create a problem?
Yeah, it will create a problem.
Because it is half cooked, na?
Yeah, it is you have the half knowledge. So the better way, if the someone person have the better knowledge in particular field, so we can go with that. The first option you have selected.
Right. So when I'm selecting the first option, means I'm selecting cohesion.
Okay.
I'm following a specialization. Means whatever class I'm creating, in that class, let's say employee class is there. In employee class, I'm expected to store the address also. Right? So in the employee class, I am writing employee details also, and the same variables I am declaring in address class. Means address class के भी मतलब address के variables भी मैंने employee में ही declare कर दिया है. And address related all the functionalities are also the part of my employee class. This is not the implementation of cohesion. Cohesion means employee class is separate, address class is separate.
Yes, got it.
Understanding, guys? So basically, when I talk about a single responsibility principle, basically single responsibility principle implementation is nothing but the higher level of cohesion. Guys, am I right?
Yes, right.
Yes.
So that point I wanted to add. Basically, rest of the things that is related to single responsibility principle, we have already discussed. But the main important part from the technical buzzwords point of view, that the single responsibility principle is nothing but the higher level implementation of cohesion concept. We are creating a class which is responsible for one thing. And there is only one reason by which that class can be get modified. Correct, guys?
Yes.
Right. So everyone is clear with the single responsibility principle?
Yes.
Okay. Guys, now tell me what is the second principle?
Open source.
Open.
Open for
Open
extension,
source.
close for modification.
Yes.
Open for extension and close for modification. Okay. So this particular principle is also dependent on which concept majorly?
Abstraction.
No, it's dependent on inheritance. So Ruby, stick to the words. Open for extension. So the moment I'm using a word as an extension, इसका मतलब क्या है?
But we can achieve it using abstraction.
How you can achieve it using abstraction? Abstraction is a process. You are once again getting confused between the terminology, something called as abstract class and abstract concept. Oops, concept. If I'm not mistaken, guys, please correct me. Abstraction is nothing but a process by which I'm going to decide which elements are supposed to be get considered and which are supposed to be get omitted. Correct, na, guys?
Yes, but here it's just a concept. We can show only the necessary data. Like we are creating the
Yes.
interface. So inside that interface, we are defining only the methods. So we are not providing any kind of the implementation over there. So we
No,
are just
it's
defining the methods.
no, but interface concept बाद का आता है. पहले class level पे if you are going to see, then if I'm going to talk about abstraction, means I'm deciding that for a particular entity there are 100 elements. From that 100 elements, 10 elements are only required from my software point of view. Then I will only consider those 10 elements. That is nothing but abstraction, if I'm not mistaken.
Yeah.
Correct, guys?
Yeah.
Yes.
So Surabhi, that is different. And abstraction is used at every level whenever you are designing any Java element. कोई भी Java element अगर मैं define करती हूँ, that is class, interface, whatever you are defining, obviously we are following the abstraction concept. Because abstraction is going to decide what is supposed to be get considered. Right? And encapsulation is going to encapsulate that particular thing under the class or interface. Am I right, guys?
Yes.
Yes, Mansi.
Right, so that is different. So when I say that it is open for extension, iska matlab I am going for a easy relationship. Can I say that, guys?
Yes. Means it will use inheritance concept, right?
Yes, it will use inheritance concept.
Yes. Okay.
Right, so what I am saying, okay, so now who will explain me the second principle? The way you have understood it, no problem. Janavi, can you try? Janavi, am I audible? Okay.
May I?
Yeah, yes, Surabhi, please.
So open. So I take an example of notification. Like if I have to push notification using email, SMS, or whatever I have to implement. So if I create a class for notification only, and in that notification I push the notification through email or SMS. All the implementation and functionality I implemented in only that class, in notification class. So if another notification is there, like I have to implement using WhatsApp on also, then I have to modify that class also using that. I also have to functionality for WhatsApp. But if I use all the notification, if I create for all the notification another classes, like notification is my interface, and like WhatsApp notification, SMS notification, and then email notification. If I create all these three classes separately, then it is open close for notification and open for extension. If I
Close
have to
close for modification and open for extension.
Yes.
So in short, whatever base class or base interface you are creating, that base class and base interface structure you are not going to change.
Yes.
Right? And if I wanted to add anything, then obviously you will try to add it by adding the subclasses, right? Because my subclasses can have the parent features plus it can have its own behavior also. So whatever additional points I wanted to add, I can add it in that particular form also. But I require to make sure that I'm not touching the base structure which I have created. Correct? So guys, this is right. This is for open for extension and close for modification. That is nothing but our second principle, guys.
Yes.
Yes.
Okay, okay. So guys, are you clear with the first two principles?
Yes.
Okay, shall we go for the third one?
Yes.
Okay, Vijayalakshmi, now over to you, please.
Yeah, thanks, Amansi. So the third one is Liskov substitution principle, and it is this principle also applies to inheritance hierarchy, and it in such a way that the derived class must be completely substitutable for their base classes. So we can say that it extends open close principle, uh, and it focuses.
Hmm.
Yes,
Okay,
continue.
please. No, please continue. Please continue.
Okay.
Sorry, please continue.
And it focuses on the behavior of a superclass and its subtypes. And we should design the classes to preserve the prototype unless we have a major change, some strong reason to modify the class. Here we can see a example. It is a very typical example for the list of substitution principle. We have a class called rectangle, which have height, width, and one class called square, which extends a rectangle. And it does have height, set height, and set width. But here, where as rectangle have same height and width, we are each time assigning the same height to the same height or width to both the variables, but it violates the list of substitution principle because it will give you error. And in this case, what we can do, we can create one abstraction layer, that is shape, and we can create a rectangle class extending the shape, and square class extending the shape class, and providing their own implementation to that. Then comes the fourth one. This is interface segregation principle, and it states that the larger interfaces should be split into smaller one, because the implementation class, so that implementation class have to override the only required methods, not all the methods which are in the interface. Uh, and we should not force the client to use the methods that they don't want to use. And it is somewhere similar to single responsibility principle. And we can see the example here. Suppose we have one interface, say animal, and we have a abstract method feed, and we have two classes, dog and tiger, which implements animal and provide their own implementation in the feed method. But the problems comes when we have to add one more method, say groom. Uh, so interface when in interface animal we add groom, we again have to provide implementation in the dog class and tiger class as well. But does tiger need grooming? No, because only pet animals need grooming, but it has to provide a dummy implementation. So in that case, we can segregate the interfaces. Like we can create one more abstraction layer that is called pet, and which implements animal and provide one abstract method, say groom. And next, dog can implement pet, whereas the tiger can implement the animal. So we don't have to have the groom method in the tiger class unnecessarily. Amanshi, do you want to add something?
Okay, now before we move to the fourth principle, Vijayalakshmi, can you go to the third principle?
Sure.
Okay, so the third principle is the Lisco substitution principle. It is one of the what you can say trickiest or you can say little bit confusing principle over here. Once again, from my understanding point of view, this particular Lisco substitution principle is the principle which is once again dedicated to inheritance hierarchy, right? And actually somehow this Lisco substitution principle is covering one particular situation, is like you require to define the classes in such a way, right, that tomorrow my child class can be a parent, right? Means I want in that way, in that particular fashion you should design the hierarchy. Means in short, actually if I wanted to give it from a real life point of view, suppose there is one particular person who is having a business empire, right? Then what is the obvious expectation? That his son or daughter will also join the business, and after the respective person's death, right, the his child can become the owner of that empire and manage the empire. Are you getting, guys, what I'm trying to say?
Yes.
Right, this is once again generalized situation, right? So suppose tomorrow if due to some reason in my hierarchy, if I require to remove the parent class, right, then his immediate child class can become a parent, right? So it should be designed in that particular way. Understanding?
Yes.
Right, means we used to say, means this is not associated to real life scenario, but ऐसा बोलते थे ना कि राजा का बेटा राजा बनेगा, correct?
Correct.
Because you require to groom it in that particular way. That is the requirement. Means any other person can become a king, but that person need to be get groomed. It should be get what you can say taught. Then he can become, correct? But his behavior should be like a king. But you require to teach him how to become a king, correct?
Yes.
Yes.
Right, so that is nothing but Cisco substitution principle. So with that, what they are saying that you should design your classes in a such a way, right, that my subclass can be get substituted in as a parent. Means tomorrow if I wanted to remove the parent, then I should able to remove it and my child will act in that particular manner. Guys, are you clear?
Yes.
Right, right. So this is nothing but the third principle, right? What is the next principle, guys?
Interface segregation.
Interface segregation principle. Now, guys, what do you think? What this principle is? Harshit, can you tell me what you understood?
Yeah, if suppose there are one interface class, so we can have to bifurcate it
Wait,
to
wait,
a
wait. You are having the interface or class?
interface.
Yes,
Yeah,
please.
so that interface we can differentiate. I mean, so we can divide into the smaller parts to analyze it in a better way for different types. Like in example, that main interface class is animal, and we have created different implementations called like for dog and tiger, like that.
Yeah, but this is not interface segregation principle. It means the example which has been shown, it is not an interface segregation example. That is according to my knowledge. As per my knowledge, interface segregation principle is actually associated to interface concept. So instead of
Mansi,
creation of one single interface, right, I am going to create the multiple interfaces.
Mansi, that was the problem statement. Here
Okay.
it was split into two interfaces like animal
Okay.
and pet.
Okay.
We
Okay.
can divide that to a different small parts, so we can analyze it in better way.
No, it's not about analyzing, Harshit. It's about implementing.
Yeah, means we should implement the interfaces like that. Whoever is going to implement that, it should not be forced to implement those methods which are not necessary for it.
Yes, exactly. Exactly. Means in case of base, if I'm having an interface, something called as feed and groom, then grooming is not the requirement for all the, what you can say, animals, right? So that's why in the example as has been properly suggested, I'm going to create a base interface as animal, which is having a child interface as pet. So in case of tiger, I will only implement animal. So I will only supply the implementation of food, right? But in case of dog, I can implement a pet. So I can implement the feed and groom both the things. Am I right, guys? So in short, in other simple words, can I say you should create a hierarchy of interfaces
Yes.
as per your requirement, right? And you can make sure that respective interface is implemented by the class. Can I say that in very simple words?
Yes.
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 Right. Means instead of putting all the things in one single interface and my elements are not required some functionality, still as they are implementing the interface, they are forced to implement the things, right? This situation should not be there. So instead of that, you can divide the functionalities into suitable small parts, right? And according to that, the implementation can be properly managed. Correct?
Correct.
Yes.
Right, that is nothing but the Cisco substitution principle. Right, guys?
Right.
Right. So this is the fourth principle, right? Another example for this particular principle, if I wanted to provide now, guys, then it will be like something, suppose if I'm having a restaurant and in the restaurant, I'm going to have a menu. So shall I create only one interface, something called as menu, which is containing all the menu related information, dinner, buffet, then lunch, snacks, everything is the part of only one interface, or I should have a proper hierarchy. That is menu, under that there will be child interface, something called as buffet interface, then lunch, then menu, and then snacks. And then according to that also, I can have a more classification. What is better? First one or second one?
Second one.
Second one.
Second one. So can you say in the second one we have implemented the interface segregation principle?
Yes.
Yes.
Right. Correct. Okay. Actually, I got the example. I was like having a feeling that the first example was the example of interface segregation. Sorry, Vijay Lakshmi. I means actually I completely forgot that on the second slide you have a proper implementation.
No, yes.
Okay. Okay. So guys, shall we go for the last principle now?
Yes.
Yes. Okay. So Vijay Lakshmi, over to you.
Yeah. So the last one is dependency inversion principle. And it says that we must use abstraction instead of concrete implementation because abstraction doesn't depend on details, but the details depends on abstraction, and it decouples the decouples the codes. Am I right, man?
Okay, so basically this principle is somewhere dependent on the situation where I'm having some container class and that container class requires the another object as its part. Means for example, car and engine. Am I right, guys?
Yeah.
Yes.
Right. Now, in that particular scenario, what they are saying ki this principal dependency inversion refers to the decoupling of software modules, right? Means actually, once again, it's a generalized thing. This way, instead of high level modules depending on low level modules, both will depend on abstraction, right? Means in that particular scenario, what they are trying to say that generally general situation क्या होता है कि high level modules are dependent on low level modules because low level modules are going to provide some functionality. Means suppose if I consider it in a very smaller way, I am having a car, but the functionality of car is dependent on engine, correct? Yes or
Yes,
no?
here it is a concrete class. The engine is a concrete class.
Right, right. So what I should do, instead of having the engine as a concrete class, I should have an interface as engine. Right? And that interface can be get implemented by multiple classes. Vijay Lakshmi, you can explain the solution, please. Over to you.
Yeah, yes. So we can see the class here, car, and which have a reference to engine class. And here we have the implementation for the engine class. All the concrete methods are here in this engine class. And solution to that will be we can create one interface called engine, and which will be having abstract methods, and the card will be have a reference to the interface engine, and we can provide, suppose going forward we will get different kind of engines, say petrol engine or diesel engine. So going forward it can implement and it can provide its own implementation. So in that way, code will be will be decoupled and reusability will be maximum.
Guys, are you getting? So what is suggested that, okay, at this point, suppose at the initial stages, if I'm creating a class as an engine, right, then only one type of engine can be get considered. But as per the future requirement, there could be the invention of different types of engines, right? And as per the car requirement, actually that engine is need to be get used, right? So either I can have a petrol engine, or I can have a diesel engine, or I can have a CNG gas engine, right? So in one car, three options are available, right? So what I should do, I should have an interface reference, right, which is a part of my class. So as per the requirement, the respective implementation can come into the picture. Am I right, guys?
Yes.
Right? I think so. This concept we use very frequently, especially when we are implementing repository or controllers or service layer. Am I right, guys?
Yes.
Yes.
Right. So instead of having the direct dependency, I'm using some interface which will help me out. मतलब कोई भी two elements या फिर two modules are not directly dependent on each other. Instead of that, there is some what you can say, there is some abstract entity, right, which will decide ki which element or which lower level module should come into the picture. Which lower level module is going to come into the picture and give a help to higher level module, that is somewhere decided by that abstract entity. Whenever this kind of situation is there, then can I say I am implementing this principle, guys? Yes, no, give the reply. Okay. So are you clear with all the 5 principles?
Yes.
Right. Now, guys, please try to understand this topic is very small. Right? Topic is not big, but this topic is very important, not only from the interview point of view, but in general, while writing the code also, if you are following these particular principles, then they will help you out. So if you wanted to become a good developer, or if you wanted to grow yourself as a developer, right, then you require to, or it is recommended that you should follow those principles. Getting, guys?
Yes.
Yes.
Okay, okay. So quickly, who is going to revise, means not revise, at least tell what are the 5 principles? Imran, can you tell? Yes, Imran, am I audible? Okay, Prashant, can you quickly revise it or mention the names?
Mansi, I need to go through again.
Okay, you are not able to remember the 5 principles?
No, I remember, but not exactly. Okay.
Okay. Okay. Now can you say, can you tell us, Prashant?
Yeah. No, Mansi, it'll be better you can ask someone. Okay.
Okay.
Yeah.
Okay.
Not
I think you're not that much comfortable with the topic.
Yes.
Okay. Okay. But you require to make yourself comfortable, Prashant.
Yeah.
Okay. With the your experience level, this is the most common questions.
Correct. Yeah.
Right. Okay. Surbhi, can you just quickly tell what are the 5 principles we have discussed?
Yeah, sure. So first is single responsibility principle. Single responsibility principle means my one class should be dependent, it should be specified only for one task. That is single responsibility principle. So in this, we can achieve it using a low coupling and high cohesion. Then second one is open for extension, close for modification principle. Like my class should be closed for modification. We do not have to modify.
Surbhi,
Sorry.
1 minute. One change I wanted to say. In single responsibility principle, it is only high level of cohesion. Coupling नहीं आता
Okay.
उसमें.
Okay.
Usage of interface is a representation of low level coupling
Yes.
or loose
Sorry.
coupling. हाँ.
So in single responsibility principle, we can achieve using high cohesion. Open for extension and closed for modification principle. Like my class should be closed for modification and open for extension. We can achieve it using is a relationship. And for example, I already told you, if I have to implement notification, there are various ways to implement notification, like WhatsApp, SMS, and email notification. If I implement all these 3 in one class, then if there is another notification have to implement, then I have to modify that on the class. So it is so that my class should be closed for modification. So the solution for that, I have to create separate classes for each implementation. Third one is Lisco substitution principle. Substitution principle is like my derived class should be substitute of my base class. If in case my base class should be removed, then my derived class should be similar to my parent class. So that is the Lisco substitution principle. Fourth one is interface segregation principle. Like my interface should not be bigger. It should be separated in a small part. So like my interface, if my one class is implement interface, then that class is not to be forced that method which is not be required in that class. So that is interface segregation principle. Fourth one is dependency inversion principle. Fifth one is dependency inversion. Like my high level module should not be dependent on the low level module. That is dependency inversion. So in dependency inversion, like we can achieve it using I have an employee class. In employee class, if I created an address, so it is like tightly coupled. So in that case, I have to create an interface for achieving address functionality. So that is dependency inversion.
Okay, 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 okay. So guys, are you clear?
Yes.
Yes.
Yes, Mansi.
Okay. Okay. So guys, once again, I will take this particular discussion as a starting point only, right? Please have a more dig into this particular solid principle concept, right? And try to check out for the codes who are actually implementing the solid principles, right? In a Java way, right? Or at least from Java code point of view, right? Try to figure out that the solutions where from OOPS concept or from the Java concepts, these particular things are implemented. And from these 5 principles, Lisco substitution principle is majorly asked because it is one of what you can say a little bit confusing principle. So, if I find any material on these each and every principle, I will definitely share it on our chat group as additional information. So at least can I say the base part about the solid principle is clear?
Yes, ma'am.
Yes, Nancy.
Yes. Right. So Vijay Lakshmi, thank you very much for presenting this particular topic. I hope you enjoyed the presentation.
Yeah, thank you, Mansi.
Okay. Now I would like to discuss the next means tomorrow there is no technical discussion because tomorrow I think so there is a public holiday. So I have not planned any technical discussion for tomorrow. In the next week, we are going to have a focus on Spring Framework. Okay, so one technical discussion will be arranged for Spring Core and 2 days are dedicated to Spring Boot concepts. Okay, so the next topic which we are going to discuss is obviously one of the important topics, that is Spring. Okay, so obviously you will receive the invitation from me for that. That is the last point I wanted to update you.
Okay.
Okay. So guys, shall we conclude?
Mansi, can we have a technical discussion on multi-threading?
Actually, the multi-threading technical discussion in this month we are not going to plan because at the starting of the month, actually, we ask the candidates to apply for the what you can say CineLearn training, right? And so that point we have covered at that particular point. And actually, Surbhi, what is the situation that for the month we have a fixed calendar?
Okay.
Okay, so suppose if you still wanted to work with the multi-threading, then you can actually separately ping me. I will share the multi-threading related course side by side. You can go for it. Or if you wanted to focus on a particular topic. Okay, one thing I wanted to ask Surbi, have you gone through the notes which has been shared by me at the day 1?
Yes, ma'am.
So
Yes,
have you gone
Mansi.
through it?
Yes, Mansi.
Okay, still you wanted to have a more information on multi-threading?
Actually, I go through only that part, like all the details regarding that. But in detail, like regarding how we can use it in a daily routine, like in a project, because I am not work on hands-on experience in multi-threading. That's why I'm
Okay.
telling you.
Okay, so in that case, Surbhi, what I will suggest that you can actually apply for the next month ka multi-threading related what you can say serial learn training.
Okay.
Okay. Or if we are discussing, it means either what is the situation, either if the suitable training is available, Synchron training is available, then we recommend ki you just go for Synchron training because it's a full day training and more topics and more detailed discussion will be there, right? And if the suitable training is not there, then we arrange the technical discussions. Okay, so it's both ways, but still, Survi, what you can do, you can just ping me. We will discuss it and we will check it out what can be get done or how I can help you out in that particular situation.
Sure, Mansi.
Yeah. Okay. So guys, shall we conclude?
Mansi, just one more thing.
Yes.
You
Yes.
mentioned that tomorrow is a public holiday. I mean, is it a mandatory one? I mean,
No. It's an optional one.
Okay.
It's an optional one, but generally, sometimes what happened, many candidates took the holidays which are combined with the Friday.
Okay. Okay.
Okay, so
And
from that
also-
perspective, I have not planned any technical discussion.
Okay. Okay. And do you have any idea how to set this optional holidays? I mean, I haven't set any after the joining.
Okay, Pranita, can you just ping me afterwards?
Yeah, sure.
I will have a one-to-one communication with you.
Yeah, sure. Okay.
Okay, ठीक है,
Thank you.
ठीक है. Okay, so guys, I think so we are good to conclude. Thank you very much, guys. Thank you very much, Vijay Lakshmi. All right, we will meet in our next technical discussions, guys.